our little community. You all know Rinat. He's, I think, one of the early adopters of CQRS and event sourcing.
For which I'm sorry. Yeah.
He blogs. He has the Being the Worst podcast, which I enjoy a lot. I think maybe you can do the rest of the introduction. He's going to talk about Flux and ReactJS and the Facebook stuff. So, Rinat.
Thank you, folks, for welcoming me here. And I really enjoyed this evening presenting before the European community, because Europe, and actually this part of the place, which probably correlates to the place where the best beer is brewed, it's the place where all the most interesting and awesome innovations in domain-driven design and event sourcing came from. Like all the event storming, all the domain modeling exercises, like they come from here. And thanks for having me here today. So I've been a .NET developer for, I think, 8 years, and I've been heavily invested before in the backend development. That's where my background is in CQRS, event sourcing, and domain-driven design. Recently, probably like half a year ago, I got involved in front-end design. And front-end and web interfaces was something that scared me completely. I couldn't touch UI unless I was drunk. And of course, you know, when you touch something when you're drunk, when you see it, when you get sober, you say, okay, no, I can't figure out what the heck I wrote here, I need to get a few beers. And it goes into endless loop. And probably half a year ago, while working with Hat Pancake project, Hat Pancake is the largest free social dating website in Sweden, and we were redesigning their architecture for them. Redesigning the backend to make it more scalable, because previously, and still currently, it runs on .NET with SQL Server, and actually performs pretty well. And then we redesigned the front end, which is ASP.NET MVC. And ASP.NET MVC still comes to me during the hard times. And then that was actually the first time where I was introduced to domain-driven design in the web interfaces. And that was fortune time, because that's when ReactJS came from Facebook and Instagram. That's when Facebook Flux came out. And in the place where before there was Backbone, there was Angular, there was Ember.js, which were creating really complicated MVC applications and UI designs. React and Flux stuff, they helped to design web UIs in such an elegant way while applying all the existing domain-driven design principles that, like, I'm no longer scared of writing web UIs. I'm not longer scared of writing really not nice-looking, but at least neat-looking web applications. And for this presentation, I wrote a quite simple getting things done application to do with ability to add items to your inbox, to check them, to star them, etc. And I'll be talking about this application in this presentation. So before we move forward, the format of this talk, actually it's already changed as we discussed. So I'll start with a probably 45-minute introduction into ReactJS and Facebook Flux. And at any time, if you have a question, please don't hesitate to ask it. Like, I'm free to adapt. It's like there is no pre-created script for this presentation. And then actually, unlike it is said here, we're going to have a small break, 5 minutes for beers, for some of the beers, of course, for food. And then I'll address really fun stuff called isomorphic web apps. It's like when your application can render both on the server and on the client side. And afterwards, I'll try to answer some more questions if you get any, and then steer the discussion into some kind of open panel collaboration. Okay. So, web interfaces, like if we look at them, they can be seen as composed from two parts, two duals, if you wish. We have static user interfaces. That's something that has been done, for example, with web forms, with various types of web components. So here, if you look at the left side of the screen, you see a view for one of the screens of getting things done application. We have a sidebar on the left. The sidebar has a few nav items, where nav item is the same component that is repeated multiple times. And we have inbox view on the right side. It has a title, task list, which in its own turn has a bunch of item components, and there is an entry form. And this is kind of static user interfaces. That's something that your designer, for example, will produce. And for example, if you use various MVC frameworks or libraries that help to build MVC apps, this part is pretty easy. You just need to create some nice HTML templates and fill it with data. The most interesting part starts when you get into the behavior part. Like when you have clicks, when you have interactions with the server, when you have server failures, when you have server timeouts, and when you have, for example, events where you click on one button and it has to update a bunch of UI components all across the page. And then suddenly, that was frequent with AngularJS, some callback on event would trigger another callback, and it would trigger another callback, and it would trigger another callback, and people get into the callback hell. And that's probably one of the reasons why AngularJS is going to die within the next few years. And behaviors, and I'm sorry, but you didn't hear it from me first because that has been repeated multiple times on Twitter already. Okay, and so behavior parts is the dynamic counterpart to the static user interfaces. In behavior, we talk about the events. Task added, user clicked, we called an external API. Everything is about events. And in response to these events happening, we have some actions that happen. Like maybe we update the UI, maybe we update the internal counters, maybe we send something to the API. And I think that these two distinct parts, not two distinct parts, but two duals of web development, they require different approaches, different design approaches. And since you're a domain-driven design community, you actually are already aware about these approaches. So if we look to the interface again, we can see that this is kind of a context. This context is composed from the components, and each component has its specific boundary, and it has a name that is aligned with the domain. We have a title, we have an navigation item, we have an entry form. The terms, there are not verbs here, but still there are terms that are really aligned with the domain of the user interface. So you can say that you can actually use domain-driven design principles to decompose a web UI that you're trying to build into small focused components which work together, which are designed to work together to produce a nice UI that is pleasant to maintain, that you can actually evolve, that you can recompose components into the new UIs. It's almost like functional programming. If you can say that nav item is a function, and you compose multiple functions into a sidebar. And actually, as we see later, in ReactJS, that's almost true. So, as I mentioned earlier, ubiquitous language in user interfaces, it can revolve around the components, which are visual elements. And names of these visual elements are ideally tightly aligned with our domain of user interfaces. So the names are visual. The components ideally are focused and reusable. Ideally, each component could fit on a screen. That's pretty much similar to what people say about the microservices. In microservices at backends, ideally a microservice would fit on a screen. Here, it's the same stuff. And fitting on a screen is just simple heuristic, which is equivalent to it's so simple that it can fit in my head. Even better, it's so simple that it can fit in my head when I'm drunk with this wonderful Belgian beer. Components are focused, they're reusable, and they are designed to be composed together. They're designed to be composed together in deep hierarchies, where, for example, our sidebar contains multiple nav items. And nav item actually contain a title and a link. Okay, and the process of designing these components, of finding the boundaries, is quite similar to the domain-driven design methodology. You can meet up with your UI design experts, sit with them, and start playing the modeling game. What would be this component? Where can we reuse this component? Which component would own this component, etc., etc. It's not so important. So on the left side, we had our static kind of visual interface. On the right side of the image, this image, we had the most interesting part, the behaviors. And we can say that behaviors here, they can be represented by events. Or in other terms, we can capture behaviors with events. And events are data structures which have a name or a contract, which is usually spelled in the past tense. User clicked, user done this horrible thing, backend server returned this horrible error, etc., etc. And ideally, our code, for example, this event contracts, they reflect the real-world design. It would be easier to maintain and talk about that. And events in the user interfaces, they can originate either from user interactions, so user does something, or they can originate from interaction, for example, with the API server. The most important part here that these events, these are UI events. They're not necessarily domain events. So for example, in the domain, we can have an event, task was created. Here, we can have something different, like task was added, or task was loaded from the server, or task was retrieved from the cache. And another not critical but essential aspect of any event-driven system is we can have a single event, and we don't know how many systems or downstream components will react to that event. So that's your pops up. And we can say that with some success, and as it was proven, for example, at the Hat Pancake project, we can take domain-driven design methodology and apply it to the visual parts, into the UI, to create this structured tree of components which are useful. And we can also take this domain event-driven design principles, which are an extension of domain-driven design, with like this tricks like event storming, event sourcing, and we can take these principles and apply that to the behaviors. And that's exactly what actually ReactJS and Facebook Flux do. So ReactJS is a JavaScript library which was open sourced by Facebook recently, and it's quite simple, it's quite focused, and it has almost only one feature, but it does it magically. So before we go into that feature, let me show you a React component. That's in essence a JavaScript with some syntactic sugar. So basically, this is JSX format, where you can nest components by writing their HTML tags directly. So this is a to-do list component. All it does, given some certain properties, it will render its content as a list of task items. And basically, UL and LI here, these are not raw HTML elements, these are also other components. So basically, this is kind of declarative function that given some state, given some properties, and here we're passing this initial state, immutable state into the function, which will wrap each item with LI components, and then we wrap that with unordered list and return. So basically, this is function. The function takes some initial state and returns a declarative UI. And already in this component, you can see that we have component nesting. React makes it extremely easy to nest different components. For example, I can have also a to-do view page, which will have title, which will have to-do list component in this squiggly, and you can have much more components. And basically, the magical part of ReactJS is that there are no UI updates in the ReactJS. So with ReactJS, you declare your user interface as a bunch of nested components. And whenever you have to change something, for example, a title or a single item, you don't change that thing. You just pass the state to the React components, and ReactJS will just figure out what has to be changed. In other words, React can redraw the entire UI in one go. So if you change one single item in the UI, you just throw the entire new state to the ReactJS, which passes it to the component, and it can effectively redraw the entire script or redraw the portion. This happens because of the ReactJS magic. So we declare ReactJS code, ReactJS components in code. It can be pure.js or it can be JS6, which is just a simple beautified flavor. When our application runs, we create instances of this component. For example, we have a component task list or to-do list, and we can have multiple instances of to-do list on our screen. And somewhere around the application lifecycle, when we need to present that stuff to the user, we render them, and these components are rendered to the virtual DOM. The virtual DOM is simply a representation of a browser object model, document model, which persists in memory. And so basically, whenever we change something in our UI, we affect only the virtual DOM. And ReactJS has a magic part, where it takes the browser, it takes this in-memory representation of HTML, and it synchronizes them. And the magic part is that it can apply really efficient differential algorithms. For example, we can have part of the application where we have a time counter or current time, and the current time can change every millisecond. However, the ReactJS, it will update the browser only only 25 times per second, simply because there is no point in talking to the browser DOM faster than that. User will not notice. And this allows to be really efficient. We do the most complicated part of building the HTML structure in memory, and then ReactJS does the magical part of synchronizing this in-memory representation to the browser. So, in other words, ReactJS allows to declare all our visual elements as components. We can nest these components, we can reuse these components heavily, and these components have basically only one primary function, which is render, which transforms this component instance into some HTML declarations. Then ReactJS will synchronize this stuff. And also another interesting part of ReactJS, unlike many other frameworks, for example, in ASP.NET, I think you usually have the code behind, and you have the HTML declarations or ASP.NET declaration. With ReactJS, it's the other way. You can have a single file, which is JSX or a pure JS file, and this file will contain both the markup and the behaviors. Like, for example, what happens when I click the button? Or what happens when my state changes? How do I render that? And this makes the components really reusable and focused. And actually, they are so reusable and focused. So, for example, if you go to facebook.com, the stuff that you see on the screen, it's generated with ReactJS. So if you fire up Chrome, if you install Chrome React extension, and you open that React extension while on Facebook, this React extension will show you from which components is every page is composed from. It will show you, okay, there is a left side navbar, there is a main page, and this left side navbar contains like multiple other visual widgets. And actually, through the React console, you can manipulate Facebook page. You can tell, okay, close this thing, open that thing, post a message.
Can you show that?
Let's try if there is a web here.
So what's the philosophy? The philosophy behind that? Because a lot of other frameworks actually try to separate the UI representation and the actual UI logic or behavior. And now you're going back into one potentially intermingled domain of representation.
Well, ReactJS doesn't encapsulate the behavior. It's just a one-way funnel. It's a functional thing. So basically, we declare our UI as functions, and functions can call other functions. So basically, you have functions, which are our components. You pass it into that, and on the outside, you have the HTML. And other frameworks, which are mainly MVC frameworks, they can contain like, okay, here's how we declare our behaviors, here's our controllers, views, and models. In ReactJS, it's just the view. So basically, the view, which is a component, and the stuff that you fill in. So React doesn't say anything about how do you talk to the API, or where do you store the logic. Where, for example, when user clicks, we add something to the task list. So in ReactJS, you will have only what we display on the screen, how do we transform this state into the stuff we display on the screen, and where do we plug the event handler. So basically, in ReactJS components, you'll have, okay, when user clicks, we fire this method, and this method goes outside of ReactJS. So it's very, very focused. And once again, it doesn't have two-way bindings. For example, we don't have a model per se. There is no model. We just pass an object, which doesn't have any event notifiers, event bindings. Each time you pass and you complete the object, and the HTML output is completely redrawn. So that's the only part that ReactJS focuses on.
Okay.
Okay, come to DDDBE. I think it says something. Oh yeah. Unfortunately, the resolution of the screen isn't as standing. Where are my tools? Apple? Oops. No. Just it didn't fit on the screen. This one. So I have my developer tools. And when you install developer tools, you get this React console. Hide this part. So as you can see, these are ReactJS components. So we have Facebook type head list, which is probably hidden higher. Let's find something that is visual. This one. Inspect element. React. Okay, so we have a use feed. So we have over. Okay, oh, here it is. That's the left nav item classic draggable container. So that's a ReactJS component. And that's a pure component, it's like a pure functions. It has only one input, props. So these are the objects that are passed to this component when it was created. And since Facebook is pretty heavy, so it takes a little bit of time to inspect this component. While it tries to compute this stuff. So basically, in Facebook, they have a few dozen of developers working on this application, and they have, I think, over 100 of components. So each of these components can be built by a different team member, and they have like a shared repository of this stuff, where they can go and actually reuse some of the existing components. And since components are focused, they do only one stuff. People can take, for example, a component called check link. That's just a href link with a checks bar, and they can reuse it in someplace else. Okay, so these are the properties that were passed to this left nav item classical draggable container, and it's quite complicated. But that's the way Facebook designed this stuff. Let's try to find something more interesting. Pages. Inspect element. Go to ReactJS. So that's left nav section. And that's the state. So basically components in ReactJS, they have two types of the properties. They have the properties that were passed to them from the higher components. These are immutable, they don't own the state, and these are called props. And the state is a different type of properties, which are owned by this component. For example, if I have password entry component, then the component will own the password text. It's his state. But no other component will own that stuff. And let's try to modify some of the components. Children, okay. Object. Yeah, I think there was some stuff that I could manipulate directly. Sure. Okay, let's do that later. So here's the fun part. So actually, that's one of the smallest components you can encounter on the Facebook site. It's just a link. So it's not href, it's not a, but that's a component that can be rendered into the href. But if, for example, they decide that they need to change how their links are rendered, or maybe they need to pass the reference link through some cleanup routine to make sure that it's not malware, they will need to change it only in one place, in the link component. And they can have multiple components, for example, message bar or a list of friends. And these components will probably use that link. I think also, if you are interested in seeing how different companies implemented and used ReactJS, you can go to Instagram. If I'm not mistaken, Instagram is done with ReactJS. You can go to Khan Academy. It's they rewrote it using ReactJS. Even Sberbank of Russia, it's government-owned company, government-owned central bank of Russia. It is using ReactJS, although in a very ugly way. Okay, so let's go back. Stopped. Okay. And since ReactJS renders components into the virtual DOM, basically by concatenating strings, we can execute that render stuff both on the client side in the browser or on the server, and then return pre-rendered HTML to the client. And we'll talk about the applications of that in isomorphic web apps section. While composing components with ReactJS, basically we end up with component hierarchies. So for example, here we have an app page which owns the state of the application currently presented on the screen. And the app page can have two components called left navbar and main view area. And main view area can have other components. So that's somewhat similar to this component decomposition we've seen on the Facebook page. Although there the components were intertwined with HTML. And pure components, these are most frequently used ReactJS components. These are just components that take some initial property object and they simply transform that to HTML. Stateful components, they are more complicated than that. They own some state. And ReactJS website contains a really nice sample of a to-do application that is basically a list of list to which you can add to-do items. And it has only two components, this component, then the bigger to-do application component, which actually uses to-do list, and it also holds some state, which is basically a simple JavaScript object, you can see it here. And it also has some event handlers. So here, for example, when we declare HTML form, and we declare that when we hit submit, then we actually trigger this event. And ReactJS will perform the binding from this function to this one, and this function actually modifies the internal state. And when the internal state is modified, the ReactJS will render magically the entire component. So basically, these two components, all you need is to have a nice to-do application. And I can actually show it to you because it's magical. Expand this one. And previously, before encountering ReactJS, I had no idea how to create this nice-looking applications. Now it makes somewhat more sense. Okay, it doesn't fit here. Okay, here. So that's the to-do list. That's the to-do app component that holds a to-do list. And these few lines of code are enough to have such nice and responsive UI. And that's, although this behavior, this quick and small tiny application, it contains both the UI and some behavior. So when we add something to that list, we change the list, and it will also increment the counter here. Like these behaviors are very simplistic. They can be done by ReactJS. More complicated behaviors are when you need to talk to the server, when you need to have complicated given when then cases. And that's where Facebook Flux comes in. But before we move forward, do you have any questions about the ReactJS and how it works to compose UIs from focus components?
Yeah.
Yes?
The question about the synchronization with the actual browser, maybe you can explain a little bit how it works under the hood.
In short, that's magic.
Yeah.
In more detail, ReactJS maintains basically, it contains a link to the actual browser DOM, and it contains two copies of virtual DOM. Virtual DOM as it was when everything started, and virtual DOM as it was rendered on the current iterations. And then basically it synchronizes the current virtual DOM and the current browser DOM, and it checks out the differences. And it can find the differences because when it prints out the virtual DOM, it enriches it with React specific IDs. So it knows that, for example, this large block of div is actually maps to the task list component because there is the same ID. And once it has the virtual DOM, which can be mapped to the real DOM, it just performs a div and emits a list of changes. For example, we need to add the div new DOM element at this node, or we need to kill that DOM element. And because it knows what has to be changed, it can batch some of the changes. For example, it can figure out that, okay, we have so many changes in this area, but what if we just take the whole big div and replace it with this div, instead of like trying to replace every tiny div inside it. So basically, it optimizes and batches changes to the browser DOM, because browser DOM is extremely slow. So in other words, ReactJS, it maintains synchronization between the virtual DOM, which is composed based on the declarative components, and it synchronizes it in a magical way to the actual browser DOM. Does this answer your question?
Yeah, more or less. Thanks.
How does it do with regard to memory consumption? Because I would imagine a virtual keeping all these virtual DOMs is more hungry for memory.
Actually, it's not that much. Because the virtual DOM, come on, common smartphones can hold gigabytes of RAM. And virtual DOM is just almost the same representation, but it's a slightly bigger object. And to manipulate the virtual DOM, you concatenate strings and you perform that in memory. And since you don't try to talk to the browser on every change, so you actually unload the CPU because you perform the stuff on the virtual DOM and let ReactJS do the heavy lifting, which it is optimized to do. So maybe its memory is not used that efficiently as it could be with optimized MVC frameworks, but we don't load the CPU. And since we don't load the CPU, we don't drain the battery, for example, for mobile devices. And everything feels snappy and fast. So it's a trade-off, I'd say. Yes.
So, one of the things which you run into if you build single-page applications using other technologies is memory leaks, right? Do you hold on to event handlers, or you put stuff, you hold on to stuff, and you start leaking memory quite badly? How does React do in that area?
Because the components are declarative, and we actually explicitly declare our event handlers, first of all. Then React, when it tears down some component, it knows that, okay, I need to kill these event handlers.
Okay.
So we no longer have these event handler leaks. And second, ReactJS actually does some magical stuff. For example, if we have a huge list of task items in the task list, ReactJS might choose to create only one event handler on the task list DOM element. And basically, whenever a user clicks on the task list item, this event bubbles up to the owner container, and then the ReactJS figures, okay, so this event happened on this element, it bubbled here, so I should actually call this user logic. So it has, not only it has fewer possibilities for leaks, but it also has fewer event handlers.
Okay.
It's components that have their own state and that do message passing. It sounds more like LNK style object-oriented than pure functional, if I understand it correctly.
Yes, that would be so if components actually did the message passing. So ReactJS, it focuses only on the UI representation, and message passing is actually outside of the realm. And so basically we can have two types of components in ReactJS. One which are pure, which are functional, and basically which take some object past state representation passed to them from the upstream components, and they know how to render that. And there are some slightly more complicated components, which are stateful components. And these components usually get the state from someplace else, from the outside of ReactJS. They can emit call event creators or create events that are sent somewhere outside, but they don't talk to other components. They don't communicate with other components. They can indirectly publish events to the entire world, or they can pass state to the downstream components. So basically there is no message passing inside ReactJS. There is in the Flux architecture, but like that would be the next step. Any other questions?
Yes. How well can I combine React for the visual part with ReactJS?
Honestly, I'm not sure. Theoretically, it should be quite easy because ReactJS, in its simple form, is just a templating engine. You take a component declaration, you pass to the directory, and you render that. And in fact, React, if we go here, that's my website. Actually, it doesn't look so nice on the screen, but still. So this is a static website. It is hosted on Amazon S3. So basically, my blogging process is I have a bunch of Markdown files, which are fed to a bunch of JavaScript. And this JavaScript contains some combinatorial logic, and then it contains some React.js components. So basically, my blogging platform is taking Markdown files, which are parsed and combined into the in-memory state object, in-memory state representation of my blog. And this in-memory state representation of blog has these domain-specific concepts like posts, tags, categories, recent articles. And this state is passed to a bunch of React.js components, which I can show you later if you're interested. And in the end, I get just a bunch of HTML files, which I upload to the Amazon S3 storage. So this is the horrible misuse of React.js, but it makes it really nice to maintain a simple blog, which can be composed, changed, tweaked. And I think if React.js works so nicely in a standalone mode for generating some HTML files, it can be used in conjunction with AngularJS. One of the caveats or culprits is that AngularJS tries to do much more. It tries to provide two-way data binding. It tries to have like this powerful data binding directives. And that's what Flux, which works really nice with React.js, tries to use. So in other words, React.js as a templating engine can fit the AngularJS mode, AngularJS world, but I'm not sure how well the React.js mentality will work with AngularJS. And back to the presentation. Okay, so I mentioned this one. And actually, one more note. If you go, for example, to abdullah.com and try to view that with React.js Explorer in the Chrome, you would not see the same component decomposition as it was with the Facebook. Simply because the Facebook rendered stuff is meant to be used in single-page application. So React.js left this React ID, which are used to synchronize. My blog is a static blog. It's just a bunch of HTMLs. So I'm using another feature of React, render to static HTML, which strips completely all the nice identifiers which could be used for synchronizing DOM. Is this something I can break? ReactJS is a nice thing, and it has the magical feature of maintaining a hierarchy of components which can be efficiently rendered to the browser DOM. But it's not enough for building really nice web applications. You need something to capture the behaviors. You need some sane way to express all the complicated user interactions and their outcomes without getting lost, especially if you have a large team. And that's where Facebook Flux comes in. Facebook Flux is a pattern, is an architecture, which was devised by, obviously, the Facebook guys. And it appeared recently, I think it became popular within like last half a year. There are multiple implementations of Facebook Flux. So you can see, you can think of Flux as a CQRS for the web guys. There is a Facebook Flux the official way. There is a Flux, isomorphic Flux from the Yahoo guys. There is a Reflux, there is Fluxable, and there are lots of implementations. And I'll be talking about one of the possible ways to talk about Flux. And although this approach diverges slightly from the official Facebook, and at the end of the discussion, I'll talk which are the differences. But that's currently my favorite one. So, we've said that the user interface part can be done with ReactJS. And ReactJS will work quite nicely here because we have a bunch of components. We can design these components using the domain-driven design process. We can have nice boundaries. We can have reusability. And since the components are quite declarative, actually, in fact, in the component, you can declare this component should be passed to this property, this property, this property. And if this stuff wasn't passed to the component, the browser console will throw errors. Now we need to figure out how to handle with the events. And Facebook Flux addresses the problem of events. It addresses the problem of callback hell. It is quite similar to the CQRS. And just like CQRS, it says that there is only one way of having change flow. For example, in CQRS, we can have a command which goes to the command handler, where a command handler can publish an event. Event goes to the view projection, which updates a view, and then the UI on the desktop client on any other application pulls the view to present the view to the user, and then the user, based on the stuff that is displayed on the screen, presses a button which invokes another command. So there is like one-way circular flow. And Flux is quite similar to that. That's a simplified Flux architecture that represents the core concepts. So, and the important part is that Flux can be used with any templating engine, but it fits very well to ReactJS. So we have React component. Here it's a single component, but it can be a really complicated tree. And this component will have a bunch of event handlers. For example, when user clicks, when user types, when user maybe shuts down some application. And when we do that, we call an event creator. Event creator is a really small and very thin method, which basically the whole purpose of that is to emit events. For example, when we add a task, we call add task event creator. The event creator can talk, for example, to third-party API or to our backend to ask it to save stuff to the repository. And then when the API says, yes, it's done, the event creator will publish an event, okay, task was added. Or if the API says, oops, there was an error, event creator will have to publish an event saying, I failed to save to the database or to the backend server. Please check your network connection. All events which are domain events specific to the user interface, they go through the dispatcher. So the dispatcher is just a central place. It's usually provided by the library, which is the gateway for all events. And if you ever need to know what is happening in your application, you can add console.log here, and every change will be visible, presented to you. And then we have a bunch of stores. You can think of stores as a kind of inverted aggregates. Stores is where Facebook guys store all the behavior logic, all the complex stuff. So store is an object which declares its subscriptions. It subscribes to events. So a store can say, I'm interested in task added, tasks loaded from the server, task deleted, task checked, task unchecked. And so the store subscribes to events. It will have event handlers, which are called when event goes through the dispatcher. And then the stores have getter methods. So there are no setters. It's not possible to change, to mutate state in the store by calling a method on it. The only way to mutate a state in the store is to invoke event creator to publish an event, and this event will go to all interested stores. And then when a React component, when we declare it, we can say that it's bound, it watches like a specific store. So a store, when it changes, it says, it means a notification, I'm changed, I'm changed. And React component, when it gets this I'm changed event, it just simply reloads everything from the store, and it updates its presentation and re-renders. In essence, we can say that whenever anything changes in the application, we can have every single component to re-render. And that is possible because of the ReactJS magic. Yes?
Question, the events can influence both properties and state?
Yes, indirectly, yes. The distinction between props and state is a weird one. The other one is actions and action creators, but I skipped them in this explanation. So properties and state, they refer to how we compose component hierarchies. So if we go back here, yeah. So for example, in our to-do application, we can have a list of items in my inbox, like the things I have to do next. And this inbox list can be owned by this inbox view, which will get that from the task store. And the inbox state is basically just an array of tasks with ID and name. And it passes that to the task list. So task list will get a copy of these objects, but it doesn't own them. And it simply draws them. And because of that, ReactJS can declare the components that are pure as pure, and it means that they can be used with memorization. So ReactJS knows that when we pass this state as properties to this bunch of components, we get some HTML. If we ever pass the same state to this section of the tree, we don't need to re-render these components. We already have the HTML. We can cache it. So that's one of the tricks that React can use.
It also implies that if you don't pass the change event on the checkbox, you will get deleted or will get when it's re-rendered. If you don't have an on change event on the task check, for example, if it's not coupled, if it doesn't emit an event that the checkbox has changed, next time you get state from the inbox view, it will just remove the state and go to the previous one, so it doesn't persist.
I'm not sure I got this.
So, because if your task checked, yeah, that's
Yes.
pure.
Yes.
So it just renders
Yes.
the state that it gets, and it's unchecked. Yeah? It's unchecked, and the user checks it, and you don't have an all change event. Next time it gets rendered, the internal state doesn't persist, so it just.
Okay, so basically what happens when a user clicks on task check, for example, task check component, although it's pure, it can have a link to event creator called check task.
But if it doesn't have it,
then there is no way to change the check here.
so if the user clicks it, checkbox, next time it will be unchecked again.
No. Okay, so basically this component can either have event handler or it cannot have event handler. If it doesn't have event handler, it's basically we can't check it.
Oh, it's disabled.
No, it's basically read-only.
Yeah. Okay.
If it has an event handler, so when we click it, the task check event calls event creator called check task or uncheck task, and then it talks to the API, and the result of this process will publish an event. Task was checked. Task was checked goes somewhere else, and it updates the stores. For example, the inbox store, and the inbox store says I'm changed. Then the ReactJS knows that inbox view is subscribed to the inbox store, so it calls inbox view re-render. Inbox view re-render basically grabs the latest state from the store, it re-renders, and it passes new state down the stream. And among the state, we have the task item with ID, which is checked. And this component is changed. So maybe some of the other components are not changed, and the previous HTML is reused. Does this answer the question? Or it is
Well, I'll do it afterwards because I think
okay. Any other questions? Yes.
Well, basically, DOM state it doesn't really exist if I understand it correctly. So basically, your DOM it's a model as well.
Yes.
And if I don't have React and I would check a checkbox, the checkbox's state changes.
Yes.
Right? So basically, if I don't have an event handler that's interested in the fact that the state might change in the DOM, then my model will never get updated.
In ReactJS, they made this really clear thing. So if you have, for example, an input box and it's a proper React component, you can't edit it. So you can try to edit it, but whenever its value changes, React sees that its state is different from the stuff you entered, and it rolls back the state. So you can't just type. Or
So
if you have a checkbox, you can't check it.
So
That's my
any
question.
behavior that's given in the browser, I mean, an input box, a checkbox, they have default behavior. You basically strip all that out, and you
Yes.
have to make it explicit.
Yes,
That's the
exactly.
idea.
Yes.
Okay.
So basically, it all has to go through the events.
Right.
And when everything goes through the events with a single dispatcher, so you have a single source of truth. And if you have, for example, a bunch of lists that represent the same inbox, all of them are updated. Actually, let me show you. Let's get to the screen. Okay. So that's the ReactJS component, and let's see. There, the slides. So that's one of the components. I call it task composer. And actually, whenever I type here, it emits a tiny event like task, text, or task name changed. It goes through all this event loop, and then it updates the component. And actually, if we switch to the React console, we'll see that. So, I'm typing. And this might feel a little bit superficial, but it makes things really predictable and easy to reason about. For example, as you can see, when I'm adding a new element to the task list, to the inbox list, it changes here, and it changes the counter on the inbox on the navbar. And somewhere here, I should have. Okay, it's probably not visible here, but there is a checkbox. Sorry, it's in color hex, sharp DDD, and it's not visible. But when I click it, as you can see here, it emits event called task was checked, task was unchecked. Let me just show it again. And every event can be inspected. And for example, when I click this one, there is a okay. So that's start. So you can check and uncheck tasks, and you can also start them. Start means that is important. And for example, I have a logic here that says show here the count of items that are started and not checked. And it is implemented on one of the stores. And this component just subscribes to the store. So basically, whenever I change here in this component, and as a developer of this component, I might have not a single clue of what the developers of the navbar were doing. But they are subscribed and they stay in sync. And probably, like, whenever I change here, this update happens simultaneously in a single ReactJS render. And actually, for example, this agenda view, it displays a list of next things that I have to do. So, and this agenda view says, whenever something changes in the store, present a list of tasks that are not completed yet. So basically, if I call this, if I click check on here, that's the same task check component that you saw on the previous screens. It should disappear. Disappear. Okay. And I think that I get to this sample in response to some of the questions. Okay, do you have more questions or additional questions? Yes.
Is it hard to have some fancy transitions with this context, since it always updates?
Instantly? It's a little bit complicated.
Yeah.
So it's possible to do the transitions. People have plugins for that. And I think at Facebook, some of the plugins were open sourced by the Facebook guys. But so nice smooth transitions are currently the current state of development of ReactJS and Flux. They require some effort. I think it's done with CSS styles. More questions? Okay, let's get back to the presentation then. ReactJS, Facebook Flux. Okay, so once again, React components. Here on the screen is just a single component. In practice, they can be really complicated hierarchies of nested components. They bind to stores, and they don't bind to specific event on the store. Stores have only one event, I changed. And whenever a store changes, the React component simply renders its state to virtual DOM. ReactJS will synchronize that to the browser. Then React components can have interaction points with the user. Like, for example, user can click the button, and when a user clicks the button, we declare an event handler. This event handler can call Flux event creator. Flux event creator can have stuff like, for example, when user clicks favorite button, I can first publish an event, user clicked the favorite button, and I can optimistically update that in the UI. Then, as the next step, I can send the message to the API, or call the API, asking it to persist that change on the backend server. And then, 5 seconds later, for example, in very rare occasions, the server can say, oops, I timed out. Then, at the end, when the server says, actually, I timed out, event creator can publish an event saying, oh, actually, I failed to favorite this photo. And we can either present a nice message, or we can just mark something as unfavored. So that's optimistic approach. The pessimistic approach, event creator can first say user clicked on the favorite button. In the UI, we can display a spinning wheel. Then we call the API in this method. Then after the timeout expires and server says I gave up, we can roll back to the spinning wheel to unfavored state and display the favorited message. Or if everything is okay, half a second later, we can replace the spinning wheel with star. Event creators are simple methods. Ideally, they're very, very thin. They can talk to the API, or they can simply publish events, which go through a single place in the application, which is a dispatcher. And dispatcher publishes events to interested stores. Stores contain all the logic. They denormalize events that pass to internal state, and whenever they denormalize a state whenever they denormalize events to this in-memory view, which we hold, they can set like polls. They can say, I changed, I changed, I changed. And interested React components can re-render to the UI. Basically, that's the essence of the Flux. And all the complicated part goes to the stores. And since stores are event-driven, we know how to test them. Basically, that's almost all the event sourcing part. We know how to model them. We know that we can say, given these events, when we call this method on the store, it should return this object or this value. So that's the stores can focus on the complicated behaviors, and that behaviors can be easily tested. The rest is just boilerplate. React component belongs to the UI, and event creators are just plumbing between the usually backend APIs. And so since we can approach this behavioral part from the event-driven design perspective, we can kind of reduce some of the complexity. And this can be done because we try to keep ReactJS components very thin and focused. Ideally, the majority of the components, or a large portion of the components, they will be pure. Given the state, given some state that was passed to them, we render this. If the state is this, then we will render this. Only very few high-level components will actually be subscribed to the stores and will change their rendering based on the changes in the stores. Okay, and the very important part, that's what a lot of Flux users got wrong initially. They were trying to change the stores, mutate the stores by changing their state directly. That's wrong. You never do that. The only way to change something in the UI or in the stores should be by publishing an event. Okay, yes.
Where would you do user interface validation? So, as a birthday valid. Okay.
Yes.
And then you publish an event saying this is invalid, and then
exactly.
Okay.
Yes, please.
What heuristics are you using, or would you use to decide which components own state or are subscribed to stores and which ones are pure? How do you decide that balance between something that's pure, or are there things that push you more in one direction than the other?
Basically, higher level components that that own state, they usually don't have any UI logic themselves. So, for example, my application page component, which is like the very top component on this to-do item, all it does is subscribes to the stores, it updates the internal state, and it passes the states to the nested components. So it doesn't have any HTML in itself. And all the downstream components, or at least almost all the downstream components, they are pure. They don't talk to the stores, but they render the HTML, and they also render some nested components. So you can think of the user interface. Let me just go back to the tree here. Oh, this one will work. So you can think of this as a tree, where we go deeper, 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 deeper. And I'd say that inbox view is a component that contains the state, and the sidebar is a part that contains the state. And it gets the state from the proper stores. Maybe it actually even makes the decisions, saying that if I have no items in my inbox, then instead of displaying the inbox view, I should display add new task view. So higher level components, they usually don't have the state. They make the decisions, and then based on the decisions, they render some of the components. So we try to balance between the components that display stuff and the components that orchestrate stuff. And that's just, of course, in Flux you can mix components and state, but this tends to lead to a messy design. Another way to answer your question is it comes from the gut feeling. You start applying domain-driven design to try to find nice boundaries for the components. You can start by putting everything in one big fancy component that does everything. Then, after implementing some code over and over again, you can say, okay, this repeats here, this repeats here, and you extract this into a separate standalone component. And then as you go, you merge, you separate components, and it's just iterative evolutionary process.
Is the responsibility of the component to do the filtering of the events, the routing?
No. The React component, it only does the rendering. Get back to the Flux. So component, it only links, binds to the store. And whenever a store changes, a React framework or Flux framework will call React component to render. And basically the component will get all the necessary state from the store and update itself. The component can have event handlers, like your browser event handlers, which can trigger event creators. And event creators is the only way to create and publish an event. And then events go for the dispatcher, which is part of the library. Different Flux implementations will have different dispatchers. and dispatcher goes to the store. So React components are not responsible for routing events. They are not even responsible for subscribing to them or even publishing them. They can only touch event creators. Of course, different flavors of Flux can have different rules on that.
So the dispatcher, it sends out, it's like a global event queue, or does it send out to specific store, specific events? Or does it have
Depends on the implementation.
Okay.
So basically, you can think of dispatcher as a simple in-memory dictionary, which knows, okay, when this event comes in, I should dispatch it to these stores. As simple as that. Of course, there can be more complicated implementations. For example, saying that when I have one event being dispatched, no other event should be dispatched. I'll just wait till the first dispatch is complete. And actually, for example, with event creators, it can be really complicated because one event creator can call another event creator, and we can call another event creator, and each of them publishes events at different steps of the lifecycle, and the dispatcher will still serialize that. Yes?
Another user validation question. So if the stores do the user validation, do you also, you just send the message also to the server, so the server also validates and returns the message that it wasn't valid? How do you handle that? So you get the store validates the message, for example, it's not valid. You also send that to the server also validates it and says it's not valid, and it returns to the store again. How do you handle that?
Okay, so basically we can say that we can put different validation logic into different parts of the system. For example, registration form, where we have to enter email. We can ensure that the email is at least looks like email by validating that inside the browser. Basically, when user tries to enter the next email character, the event goes through the event creator to the dispatcher to the store. And then we can say if the new character is invalid for email, or for example for age, we do not change the store state, we just ignore it. And then we can say that when user types, we publish events, and once every, for example, when user stopped typing, or once every 1 second, we try to validate with the backend. This can be implemented using reactive extensions from JavaScript, for example. And then the React component will trigger an event saying, or call event saying, validate this email with the server. This additional validation goes to the API, and then creator will publish event saying, email is already in use, or this email is okay. This event goes to the dispatcher, this goes to the store, and the store knows that this is a server-side event, and it somehow appends it to the in-memory list of errors associated with email field. And at this point, for example, we can already have email that was filled, but the server rejected it. So it will just append that by showing asterisk, or it will be the duty of React component to decide how to display the specific error. So all validation errors, they will be accumulated at the store. The errors which we can prevent, the store will simply not let us enter this invalid character. For example, we can discard all attempts to enter letter in age field. And of course, when user finished composing the email, writing the email, if API said that this email is invalid, we can simply disable the submit button until the user modifies this field and the email is actually considered to be valid by the API, then we enable submit field. But that's one of the possible implementations. We can completely skip the client-side validation, for example, and go run every change from the API if the user wishes to. Yes, please.
Is it also possible to push from the server an event to the event creator? Or?
Come again?
It's also possible that you only, from the server side, from the backend, push an event to an event creator?
Yes, that's possible, but it's not essentially pushing, it's polling. So, for example, somewhere in the application, we can have an event poller component, or it's not even a component, it's a separate service that polls the server, for example, through WebSockets or services, or does short polling or long polling, whatever is needed. And whenever a new events are pushed by the server, it will dispatch them to the dispatcher. And then interested stores can be updated to that, and interested React components will update immediately. For example, that's how you can do user-to-user messages. So if a user has a new message or a new user notification, the polling component will dump that to the dispatcher. Interested stores will normalize these events into the state. And there can be, for example, a small React component that shows a number of unread messages. It updates and it shows a nice star. Does this answer your question?
It does.
Any more questions? Okay, and I think this can be a time for the break. 5-10 minutes, I guess, for the beers, for food, and afterwards we'll talk about a slightly more complicated scenario that you might not even want to use in your applications. It's isomorphic apps, where you can render HTML on the server for fast page load, and then the application turns into a single page application. Thank you. During the break, I had really nice feedback about the difference between the pure components and components that are on the state. The analogy was about the aggregate roots. You can think of stateful components as kind of aggregate roots, which load the state from somewhere else, from the Flux framework, for example, from Flux stores, and then they pass the state to the downstream components. This is somewhat similar to the aggregate roots, which are the point where you get the state from the repository, for example. Although the big difference is that in aggregate roots, you have only one aggregate root, while in ReactJS component hierarchies, you can have multiple stateful components within the tree. But that's just nice, one of the ways to think of it, probably. So people were asking me to show the code. Which part of the system would you like to see first? Okay, so this is the app page component. That's the component that is rendered. So basically, we render that in the browser, and this is a stateful component. As you can see, it is wired to two stores. It is, oh no, sorry, it's not wired to two stores. It's wired, yeah, it's actually wired to two stores. It's wired to the task store and the app store. App store is the store which it's kind of a global store per application. It tells which page I'm currently looking at. What is my current view? What is the title of my document? And the task store, it's the store which contains a list of all the tasks in the application, which are currently loaded on the client. It can tell what's the number of unchecked inbox items, or what is the number of starred unsolved unchecked items, etc., etc. And when the React component loads, the React framework or Flux framework will call this method, get state from the stores. And basically here, we just get the store instances from the environment, and we'll populate the internal state. And this state is actually passed to the render function. So basically, this component, it doesn't have much of HTML, or aside from that, some layout containers. It mostly passes the state it retrieved from the stores to downstream components. Here we have important viewSelector component and side navs. ViewSelector component is an interesting component. It's the right side of the screen, and depending on the current application state, it will actually render different content. Let me show it here. So basically here, this component is bound. It's a pure component. Yeah, it's pure component. But based on the page property that was passed to it from the application component, it will load and render different component. So if the application page component says, okay, currently you need to display task with this ID, then it will render task view component. If the current application page is agenda, it will render agenda view component. Otherwise, it will render inbox view component or just some blank filler. So as you can see here, the current page is retrieved by the app page component, which it passes down to the ViewSelector component, which makes some decision, and then renders some downstream component. So that's we kind of decompose the functionality. We break it down into multiple levels, just much like functional programming. And the task view component, which is currently it's hard to see. The task view component is kind of aggregate root here because it talks to the task store. And it displays, it knows which task it has to display because it has task ID passed to it from the properties. And this is specifics of ReactJS. We can declare that the component is expected to have these props passed to it by the initiator. And if we don't have, for example, a task ID, then the development console will throw an error. It's a really nice way to strengthen your code. And so the task view, all it does is, based on the task ID that was passed to it, it will get the appropriate task, detail, task object from the task store. And whenever we change the task object behind the store, then the store will say, I changed, I changed, I changed. And if this task view is loaded somewhere on the screen, then it will re-render. And as you can see here, we have a bunch of downstream components, like pure component called task check and task start. As you can guess, task check component simply renders check from check. Task start renders the start thing. And actually, let's look at that. So task start is a pure component that gets passed a context because we need to invoke event creator, and it is passed the task object. And then we simply, that's my other way of rendering star. Because you can actually, with ReactJS, you can implement reactive dynamic graphs. Because SVG is part of HTML, and you can manipulate and change SVG nodes on the fly with ReactJS. So, for example, we can have a ticker application, which displays, which gets updates from the stock server maybe 100 times per second. And then the ReactJS will synchronize every update with the browser only 25 times per second. But that's a side note. So basically here, this component, based on the fact if the task was flagged or not, it will just return either the flagged SVG or unflagged SVG. And also this pure component, it has an event handler. So here, in this SVG, we have onClick event handler. We're saying that if somebody clicks this SVG, call start task. And this function will be called. Basically, we just we execute start task event creator. And now for the difference part. I mentioned that my explanation of the Flux was slightly different from the Flux by Facebook. In Flux by Facebook, they don't have events and event creators. They have actions and action creators. And there's different people, and even the owners of the Flux idea, they're sometimes so confused about the actions, so sometimes instead of action creators, they say actions, or vice versa. That's why here I used the term events and event creators, because that's something that is, first of all, it's hard to confuse, and second, it's more, I guess it's closer to the domain-driven design community and folks that have been practicing event-driven design. Okay, I guess let's look at the start task action creator. That's actions. So this action creator or event creator, all it simply does, it calls the backend server, telling it to update the task with these methods, with this payload. And when the server responds, when the backend server responds with the result data, we either dispatch event saying task start failed, that's badly named event, and that's properly named event. We publish event task will start. And for example, we have a store called task store, which is interested in that event. And whenever there is a task start event, then the Flux framework will invoke this method. And here all we do is we update the internal map, which is a memory object, and we say bump unchanged. And then there can be a component which actually is interested in getAgenda method, because it displays items that were here. There's a language disconnect in some parts of the old code. I call it flagged. The new code is start. So flagged and start are equivalent. So if there is a component that displays agenda and some of the items was start, this actually affects all agenda views. And the components that are interested in this view, they will get a notification. They will get the view state from the getAgenda method, and then ReactJS will render stuff. That's how it goes all around. Does this code clarify anything? Do you have any questions so far?
Is there like a guarantee that the event is always delivered to the store, or if it's dispatched twice or something like that?
I'd say that happens in memory in JavaScript browser.
So yeah.
So it's pretty much always. You can get like delivered twice or at least once when you start talking to the network. When you can have network partition and things go weird. Then in that code you absolutely must make your event handlers idempotent. But here you don't need to worry about that. And one additional thing, this code is pretty much runs on a single thread. So you don't expect to have a lot of race conditions here.
Is there some built-in mechanism to synchronize events, send them to the server and get the events back?
What do you mean?
Say, for example, that some extra events would come in and you just overrule the client's events and you get the ones from the server or something.
I'm still not sure I follow.
Let's say, for example, that you add a user and that it applies into a whole series of events on the client side. If you actually want to overrule them with server-side events, well, maybe we should know.
So basically, one important thing is that events that happen in the UI, they are not 100%. They're not always related to the backend events. So in the backend, we can have domain-specific events, the events that can be event-sourced or that can be sent to multiple server instances. However, when these events get to the browser UI, they can be enriched, they can be composed, they can be mapped to different objects. So, and that's where I guess you would apply overruling or overriding.
Maybe a good example would be a disconnected client, occasionally disconnected client that would say, okay, we get events in from the server and they rule all the local client events.
Here I would model the disconnect concept explicitly. So, for example, I imagine I have my to-do list and I'm banging it, and item was added. And then at some point, like I get disconnected. And then the event creator will say, failed to ask to add this item, failed to add this item, failed to add this item. I can still display the stuff that I added on the screen, but since this event was, this task item was failed to be added, I can display it gray. Or I can have different store that caches all failed to add stuff, and it will actually be a small list of the things that are yet to be synchronized. And when the client connects, or when the user tries to click synchronize explicitly, then since these non-synchronized events are persisted in some store, I can try to send them back to the backend for the event creator, because the user will click synchronize. The synchronize will call event creator. The event creator will put the events to be synchronized from the store. Or maybe these not events are synchronization DTOs. Try to persist it to the server. If persisted, it will publish an event in the UI saying, this item was synchronized. It's okay. Make it black. It's okay. It's okay. So basically here it has to be modeled explicitly, let's say. Because then you can get into really interesting scenarios that you did that and somebody else changed the task item offline on different machine. And now you need to merge. More questions? Okay then, let's talk about one tiny and simple thing. Well, relatively simple, but fun. Isomorphic apps. Let's see. Where's that? Okay, I mentioned that. Oh, and in this presentation, in addition to calling actions, events, and action creators, event creators, because they kind of make more sense and cause less confusion in teams. While talking about the stores, I said that the stores have declared which events they are interested in. Actually, in the original Facebook Flux, it works the other way. Components register callbacks with the stores. So whenever something changes in the store, there's a callback called to the component. But in the version of Flux that I'm using, it's Yahoo Flexible. That's the version that the Yahoo team is using to write their mail application. They're trying to compete with Gmail. The store subscriptions are declared, but it's to a test. The reason why Yahoo team decided to make store subscriptions declarative is that because they want to have their application isomorphic. Isomorphic app basically can be demonstrated by a problem Twitter had, let's say, a few months ago. Or maybe even more than 2 months. Basically, at some point, Twitter was a single-page application. When you load a traditional single-page application, when you go to Twitter, for example, when it was single-page, several things will happen. First, you load the HTML page, and this HTML page will refer to a bunch of JavaScript files. And there is nothing else. Basically, probably the HTML page itself will say you need a JavaScript working in order to work with a single-page application. Then the browser goes one by one and loads these JavaScript files, which are a single-page application. And then the JavaScript is parsed, instantiated in the browser, and based on the current route that we have in the navigation window, we decide, okay, we're actually displaying this page. That's our current JavaScript location. And based on that location, the browser will go talk to the server, fetch the data for this display, and then render the HTML templates, and then display them to the browser. That can take some time. And actually, if you are on the mobile connection, it can take some time before you actually see the page you are looking for. And in Twitter, this affected a key performance indicator called time to tweet. Basically, when somebody went to the Twitter page, for example, to his profile, it took a user maybe a few even seconds before they actually saw the tweet dialog. So they decided to change that. They decided, instead of sending a bunch of JavaScript stuff to the client, where this JavaScript stuff will actually go talk to the server and get more data and then only render the HTML, they decided to perform this operation in memory on the server and then send the rendered display HTML stuff to the client immediately, so he will have something to see already. And then only after the HTML is loaded, the browser will load additional JavaScript file and instantiate the proper server single page application. And that's what isomorphic apps are about. Basically, on the first page load of isomorphic app, you get first HTML, and then you get the state for the single page application. And then when the single page application or client-side application is loaded, then you perform all additional manipulations on the browser side. You get just new JSON from the server, and you update this on the fly in the browser. So single-page applications, they have a few benefits. First, you get a really fast first-page load. Second, these applications are friendly to search engines, because if you have an application that requires JavaScript to display content, then probably most of the server engines will not be able to index that. Even Google is not able to index that. I think I was browsing some bank site recently, and it used, like, you know how Google displays, if you visit a site and it has a bunch of subsections, it displays small subsections, for example, about, contacts, and phones. And this bank had the text behind this subsection saying, you need to load JavaScript. You need to load JavaScript. I'd say that's not very search engine friendly. And additional benefit of isomorphic web apps is that it still works with the old mobile phones or old browsers that don't support JavaScript. And actually, let me show you how this happens exactly. here I have my inbox. This magical button disables the JavaScript. So okay, so my JavaScript is disabled. Now let's browse. Actually, it still continues working. And of course, I would not be able to add anything because the JavaScript is disabled. But on the browsers that have partially disabled JavaScript, that will continue working. Or I can work like this. Go here, check this. Where's the start button? Yeah. And I do page refresh. Because I'm running Node.js locally on my development machine, and actually this application has been running for quite some time, it will take a little bit of time to reload, but it will happen. Actually, in production, since this all happens in memory, it will be almost instantaneous. Did it freeze? Check.
Sure.
Oh, it refreshed. And actually, if we go to the page source, we'll see that there is a bunch of HTML, which represents which was sent by the server, and then there is a state. That's the state of the stores that was sent by the server. So how actually Facebook Flux works is that whenever there is a page first request and a user or a browser requests some URL, it will parse this route locally on the server side. Sorry, not locally, on the server side. It will see that this route is associated, for example, with a page called inbox view. And according to this route, when inbox view is loaded, maybe we need to trigger these events, call these event creators. Then browser, while still serving this first HTML request, it will execute these event creators, and event creators might talk to the backend database. And this talk will happen between the browser, between the server and some backend APIs, which probably are located within the same network. So it will be really fast. Then server will actually publish these events, send these events to the local copy of stores, which are residing in memory for this request. It will populate the stores. And it will know which stores to populate because stores declare their event subscriptions. Then it will take the component which we need to render. It will pass the stores to that component. It will render the HTML. It will send HTML to the client. And at the end of the page, it also serializes stores and send the stores store state to the client. And then on the client side in the browser, if first I will get the HTML will be displayed in the browser. And within that second, which passes between the moment I got the HTML and I do something, the browser will also load all the single page infrastructure, what are the components, and rehydrate the stores, so that any interaction from now on will work as a normal single page application. And the flexible implementation by Yahoo, which I'm using, it allows exactly that. I'm using it mostly for fun. You wouldn't need to use that in every single project, but you might be interested in using isomorphic apps if you have to support older browsers, or if you have to, if you have a social network which have to be searchable, or just for fun. So basically, React and Flux, they not only allow developing relatively complicated applications by decomposing them into simpler components and distributing that work around the teams, but they also allow to build isomorphic applications, simply because ReactJS can render HTML both on the client and on the server, and we can just simply pass the state from the server to the client. Any questions?
Yes. So,
yes.
ReactJS renders it through the help of Node.js on the server? Or?
Yes.
Does it matter? Can it run on some other engine?
Come again?
Can it run on V8 engine or something? What is it?
Node.js is V8 ability. So
yeah, but if you host it like in an ASP.NET and you see
it should be able.
Should be.
But there is a problem because ASP.NET MVC. Oh, actually, there is, I believe, React.NET that can render React code on the server side. One of the teams that I've been helping, like they were trying to start adopting ReactJS just to learn, because currently they have really complicated ASP.NET MVC application, and they're trying to break down the backend into decomposed microservices, which can be deployed separately, and they try to rewrite their really monolithic ASP.NET MVC. So initially they were looking to using ReactJS on .NET, but that wasn't a good thing, because I'd say ReactJS and Flux, they work much better with Node.js ecosystem. Especially since Node.js is usable within Windows. More questions? Or we can start moving to the open panel discussion. Oh, yes, please.
I guess you could just, well, it's a shell. You know, you could just host that part in Node.js and have a backend which is C#.
Oh, yes.
In IIS or whatever.
Absolutely, absolutely. From this perspective, basically we can have a backend which exposes an API and which contains like all the complicated logic. Persistence, maybe synchronization, maybe scalability. And then Node.js, which is the front server, which hosts Flux, is a relatively thin application, which is focused on the UI interactions. Yeah, mostly. And the backend, I personally prefer Go as of recently, but it doesn't really matter. You can use .NET, you can have Erlang, Haskell, or whatever fits your team or context. Okay, any other questions? Okay.
How much does it take to interact with designer? For example, you have the guy who whose output is beautiful HTML, and then you need to split it up into components. And what happens if there's a big redesign of user interface? Is it going to be painful, or
it might be painful?
Very painful.
It might be very, very painful. The reason for that being is that designers are not involved in the development feedback loop. If they're not involved with the development loop, they can come up with beautiful designs that look nice, but that are a huge pain to implement. Even if you get a couple of bottles of vodka, like no chance of implementing them. Or the implementation will be so horrible and painful that the next generation of developers that have to maintain the application will have to Google the location, buy a gun, and come talking to you. Ideally, when working on UI redesign, if that's not a ReactJS application and the team wants to try to migrate that, the ideal approach is to try to find a vertical slice of application. For example, maybe a bunch of separate pages that can be implemented React as a standalone. They can talk to the same backend API, but they'll be served by a Node.js server, and that separation will be hidden by the, for example, load balancer. If we're talking about redesign of existing React.js application, where we have already components, then that's much less painful, because we already have kind of domain language, UI domain language captured in the components. And maybe half of the components can be reused. And since the components are reused, since they're already used in the existing application, we just reuse them indifferently. Maybe we just shuffle the button around the place. That becomes easier. Of course, ideally, like this has to be a couple of iterations. Like we try a new design, we deploy that, we see how it works, we see what QA says, we see what users say, and it's with React.js and this kind of decomposition. It's possible to have this iterative design in very short and focused loops. We change one small thing, we change one small thing, and if something is painful, we say back to the designer immediately. So basically, redesigning or modeling a small part of the application, it can be perceived as a domain modeling exercise inside the user interface domain. And we can say, okay, let's try a few iterations, building a prototype, and we discard prototype at the end of the phase. Or at some point, if we have a prototype that is good enough, we'll keep it and move from there. Yes?
So how difficult is it to use React within an existing application? For example, within an existing page, can you create an island of React that does something? And can you also, in a React application, break out of it easily and then do jQuery stuff or whatever in there?
There are a few caveats though. First, to use ReactJS inside an existing application. So basically, if you have AngularJS application and you want to render a small part with ReactJS, ReactJS basically requires a DOM element to which will serve as a container. So basically, we say like div side nav, div with ID side nav bar, and that's the stuff that is hosted by ReactJS. And then we instantiate ReactJS component with this node and pass it some state. And then it will render its template inside into this container, and it will maintain the synchronization.
Okay.
It's possible to use ReactJS with jQuery. Although one of the benefits of ReactJS, for example, when you talk with that, it doesn't expose raw HTML underlying DOM directly. It's basically you're talking with declarations. And for example, when event is published, and you get this event passed to your handler in the ReactJS component, that's not a raw event. That's a synthetic event, which basically it's almost guaranteed to be the same on all the browsers. So you don't have to worry that on the Internet Explorer version 6, we died in pain, you will have these fields populated in the event. And on Chrome, the latest, you'll have different fields populated in the event. React magically will transform and merge everything to a single event. And of course, given this synthetic event or given this DOM handle to virtual DOM, you can get to the underlying DOM, but ReactJS will make it hard for you. Actually, if you're trying to set the raw HTML of some DOM element, you have to set HTML on an object whose name is dangerously set in your HTML in all caps, and it's with 2 underscores in the front. So it's possible to use jQuery, it's possible to use any library that you want, but React makes it hard because it kind of kills some of the beauty of ReactJS. For example, the way it abstracts away and hides browser quirks.
Yeah, but if you have a control from jQuery that you have to use because it just does something magical for you that you really want to use, but you want to do it the rest
You can try to combine.
Okay.
Although I'd say the process of combining this, like ReactJS and Flux, they are new, yeah, and mostly they are used on greenfield projects. The projects might be small and focused, and so far as I've heard, effects of combining ReactJS with other worlds, they start they increase complexity. Basically, they miss it. So thread with caution.
Yeah, but for example, simple calendar pickup or calendar date selector, does it have something like that?
I'd say somebody already did that. At the very least, you can go to Facebook. I think there should be a calendar selector there. You just rip that direct component and restyle and use it. That's one of the nice things of React ecosystem, is that it has this amazing interactive console that makes it easy to debug all the things that happen. You can actually go to the sites and see and learn from the amazing domain-driven design process that they already applied without knowing it. Like they said, okay, so we have the side navbar element, and this element has these properties, so you can just rip it up and reuse it. Of course, watching for the copyright, etc., etc. Anything else that prevents you from going home and starting to write the next application completely in ReactJS and Flux? Actually, during the break, I also had a nice feedback about the AngularJS. So I said that AngularJS is going to die in a few years. To be more precise, it's going to die for complicated projects. Because AngularJS, as MVC framework with two-way data binding, it doesn't scale well for complex applications. So it would be awesome and really nice for small applications and small prototypes. But as you continue adding more logics, more pullbacks, more events and interactions into the AngularJS powered application, you're going to start getting a lot of unforeseen consequences, a lot of side effects, and it's going to be messy. ReactJS might have additional effort that requires to set it up on the new application, because you have to pick up the stores, you have to set up some initial wiring, but then it scales much better with complexity. So for complex projects, ReactJS might work better. For smaller and simple projects, like for example to-do list, AngularJS might work better. Yes?
You
say Flux is a framework or a library?
Oh no, it's neither. Flux is a pattern.
Pattern name.
Yes, similar to Securus. Securus is a pattern. And when Facebook introduced Flux to the public, they provided one of the implementations of the Flux. And they were actually quite amazed that community responded to that. And there are like lots of, at least half a dozen of different Flux implementations right now. Some people, for example, I think it's with Reflux, they don't have, they have only 3 elements. I don't remember which of them, which they skipped. So usually you have React components, store, event creator, event, and dispatcher. And folks from Reflux, he just stripped one of the parts and wired everything directly. Although the project is mentioned quite a lot, but it's maintained by one guy. So that's one characteristic of the application. So once again, Flux is a pattern which has multiple implementations. And I personally currently use Yahoo Fluxible implementation because that's what I'm most familiar with, and because it allows to have to build isomorphic apps without a lot of effort. And that was actually what we tried to use at the HappyPancake when we were studying this problem. Okay, and also I had a question before the discussion. Oh, okay, go ahead.
Can you combine this with CoffeeScript or TypeScript?
Of course. Actually, the ReactJS transpiler and folks from the Facebook, they use ECMAScript 6. So the ReactJS components, which are JS6, so like all the HTML elements inside the JS code, you can also add ECMAScript 6 on top of that, and that's pretty much already implements some part of the CoffeeScript. And since ReactJS, actually, if I'm not mistaken, there are already some Flux libraries that are implemented in CoffeeScript. In particular, there is an amazing immutable JS library that was open sourced by Facebook recently, and they use this immutable JS with React and Flux as well. Basically, what they're saying is that the state is composed from the objects that are immutable. And we know that we can't change the object, we can only clone the object. So for example, we can't change the tree, but we can create a new copy of the tree that has part of the nodes replaced. And because of that, it makes it much easier to have pure React components. The components which will render efficiently, because you know that, what's the word? If the object instance didn't change, you don't need to do deep compare on the object to figure out if the inputs of the component changed. You just compare by reference, and if the comparison by reference returns true, then you return the same cached HTML. Okay. And before the presentation, I was asked a question about how do different backend services fit into this scenario. So, for example, if you have microservices or implemented in Go or big bad ASP.NET web API, you can have this. Basically, it doesn't really matter which kind of API, which kind of backend you have in the scenario, because it's kind of parallel and separated from the front end. Of course, ideally, when you're developing your backend, you would be working on the front end at the same time, just to ensure that the APIs which are exposed are usable, and yeah, that they are usable. And the interaction point between the, for example, Flux front-end application and the back-end application would be this event creators, because that's where we talk to the API, and that's where we get the API responses and publish events. Oh, actually, one additional thing about the Flux that I forgot to mention. Just close this thing. Here. When isomorphic Flux runs on the backend, everything here runs is instantiated within the request and runs in memory. From the event creator, when we talk to the API, we can talk directly, for example, to the local implementation that runs on this memory. So we talk directly. However, when this entire infrastructure is loaded on the client side, and we're running on a single page application, we actually, when we talk to the API, we first need to send the request to the backend server somehow, and then it will talk to the service on this backend. And Facebook Flux folks already provide a component called Fluxible Dispatcher, I believe. And this component acts as a transparent proxy, where you call the same service that, for example, create task from your code. And if this code runs on a single page application, it will be proxied to the backend server and then applied there. If this code runs on the backend, then it will be passed directly to the server instance. That's just a tiny note. Okay, any more questions? Okay, that's yes.
Do you consider things like Elm? You know the Elm language where they?
No, I'm not familiar with that.
They know that.
Is it in our functional language?
A functional language, but it's specific for the browser, and it also works with events. It's reactive, so.
Does it transpile to JavaScript?
It's response to JavaScript. Yes.
So I'd say then you could probably use Elm to write your stores.
Well, it's way deeper. It even offers some kind of events, but maybe we should look at it later.
One of the beauties of the current Flux implementations around the world is that they don't always try to be like a full framework that dictates the way you do. For example, the Yahoo Fluxible implementation is composed from a bunch of libraries, and actually in their sample implementation, they combine these libraries together. So if you want, for example, to replace the default dispatcher, store, and event creators with your own logic, you can easily do that and keep the default ReactJS implementation. Or you can keep the stores, and store makes sense, but completely replace the dispatcher with something else. Once again, Flux is not a single bullet first. It's not a framework, it's just a principle which has multiple implementations. And the stuff that I was talking about, it's aligned with Yahoo Fluxible implementation of Flux, but there are many others. And I hope it made some sense about how Flux and ReactJS can be aligned with existing domain-driven design methodologies and event-driven design, so that we take these methodologies, we take all the experience that we captured within these methodologies, and we reapply them. Usual old-school DDD design to model and extract components, and then compose UIs from these components, and then newer event-driven modeling to do event storming, for example, on all these UI events with designers, and how to evolve that iteratively. Yes?
The store element is a little bit unclear for me. So how would you decompose your stores? How would you define your stores based on what?
Well, that's a very good question. So in event-driven design, especially for example when we're talking about the event sourcing, we know how to decompose aggregates, because we say that aggregate is a combination of behaviors that closely relate to each other and that work with the same state. And theoretically, if your aggregates are expressed and specified with use case specifications, you can actually take some of the event handlers from one aggregate and move that to another aggregate. And the way we model aggregates, the way we find aggregate boundaries, is that we try to have aggregate that is not too much, is not that large, is not that small, and that all the behaviors related to that are kind of fit well together. If they don't fit well together, then we take some of the event handlers and move to a different aggregate main. The same is with the stores. They're not aggregates, but the principles still apply. We can try to see that, okay, this store is too large, it handles too many events. Is it possible to maybe break it into two smaller stores without hurting the internal implementation too much? Maybe we can see that at some point that, for example, my task store, it does handle all tasks, and it also builds agendas, and it also, handles attachments. And it feels wrong. At some point, it might feel wrong that this aggregate store is too large, that it doesn't fit on a single screen. But then the attempt, according to the event-driven design, would be to try to break it into two aggregates or three smaller aggregates and see how it works out. So obviously there is no strict rule of the thumb how to break or how to merge aggregates. It's all iterative design. However, the heuristics are to try to find events and related state that fit well together, that are small enough, that fit in a developer's head, and try to implement that as a single store. If store becomes too large, it feels that it handles too many events, try to split it. And repeat, 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 repeat.
Okay. Then maybe the store name is a little bit confusing.
It is.
Yeah, if it's not really an event store or something, right? It's more like a state of an aggregate that you just define based on something.
The term store was coined by the Flux guys, and by the Facebook Flux guys, and they're a bit behind the community on event-driven design. Actually, when I was talking to Bill Fisher, I believe, about the Flux, it came as a surprise to him that actions that better be named in the past tense. Something happened, and that's events. So it's like this Flux terminology isn't really aligned with the event-driven design. Maybe there is a better word to store. I just didn't want to change too many words in my presentation, because then it would confuse everybody when you start Googling up and start reading official Flux implementations. So store is not the best, but at least it kind of sticks. Yes?
But it doesn't actually store anything, right?
It's
it's not meant to be funny, but well, it's kind of funny. But, no, I mean, I see it as it's basically like it's your domain. The domain here is presentation, and this domain contains all the presentation logic, if you will. It gets its state from, I guess, the model, the virtual, or what is it, the virtual DOM model?
No. Stores get their state by events. So basically stores...
Only by events.
Yes, only by events.
But the event is the diff. I mean, the event
No. Sorry. So events that go into the stores, we generate them. Okay. So the virtual DOM is nowhere to be found here. It's only inside the React components.
Yeah.
The stores get event like task was added, task was loaded from the server. So you can think of a store as projection, in-memory projection that projects UI events, our UI events specific to our domain, to the in-memory views. It stores these behaviors, it stores these views in memory. And then when this event projection, it updates the in-memory view, it notifies everybody who's interested, my in-memory view state changed. And then the components reach out to the stores they're subscribed to, and they pull this in-memory views. And they bind this in-memory views to the React components, and React components then start its magical dance. It renders, it calls the render method, which actually creates the virtual DOM, and then internally React will actually synchronize that with the browser by emitting like maybe HTML changed. But these HTML changed events, these DOM elements, they're all hidden React components. And this is our UI domain logic fusion.
Okay.
Yes.
So in event sourcing, you typically store a stream of events and then you rebuild your aggregates based on those streams. How would you rehydrate your store after you load up a page? Would you raise an event that has all the data in it then? Or?
Yep, that's one of the possibilities. And that's actually quite how it's usually done in Flux implementation. And that's actually how it is done in my getting things done. So when the page is loaded, actually the application invokes like load data event creator. Load data event creator talks to the API. It gets a bunch of gets the current state of the application, like tasks which are stored in the tables, and then it meets events like inbox loaded, and it contains an array of events. Agenda loaded, current project loaded, etc., etc. And then stores, they subscribe to this loading process specific events, and they mutate their internal memory state.
So it actually does have state. The store does have state. It has the internal state. It needs to
this is in the internal.
Yeah, it's not. It gets its state obviously from the events, like you just said. But it does have to store it somewhere. I mean,
in memory.
Yeah,
internal, of course. Sure. And nobody can actually touch this state except from getting it or emitting the event.
Exactly.
you say from a CQRS perspective that the event creator is actually converting the client-side events into comments that get handled by the server and then return events?
We can. I was tempted to call event creator a command handler because it's somewhat similar, but it didn't resonate well because in a CQRS with ES, our command handlers are fat. That's where all the domain logic resides. And Facebook guys, they found out that event creators work best when they're very thin. When basically you squeeze them to make them as thin as possible and push the complicated parts either to the store or generalization or back to the API. This way, like there is a nicer balance of components, and you get more reusable components, and you get components that are easier to test. So, in essence, event creators are just very, very thin methods that emit events, and they can talk, for example, to command handlers in the API. And the rest of the API can be implemented, for example, using CQRS. Yes? Oh.
Well, I can have questions. What about waiting spinning wheel, as you said, when, for example, pessimistic concurrency? Doesn't it violate diagram when you display spinning wheel right from the event creator, as I understand?
Oh, okay. No. So basically, when we say we go with the pessimistic approach, event creator we call like favorite or post message. Event creator first it says we started posting message and publishes this event. This event goes through the loop and it immediately updates UI. Then this event creator is actually still being executed. It's waiting for the API because it said after saying the comment is being posted, it calls the API and says actually post the comment. And then while before we get the response from the API or before we get a timeout, the store state will be like posting and the React component will display that. When the API says OK, then the event that will be published is like a comment was posted. The store will update the state OK, and then we'll make it good. If the API times out or returns something bad, then the final event will be something like posting actually failed, sorry. And this will be updated through the stores in the UI. So it means that event creator can run for some time, and while running and while waiting, it can emit multiple events. Yes?
Can you get access to an event creator when it's running to cancel it, for example?
I think it shouldn't be possible. I don't know. That's the scenario I haven't thought about yet. But I'd say it would have to be modeled explicitly somehow. Basically, in that case, event creator, it's probably not event creator per se, but it will be some standalone service, which you could access from multiple event creators. So event creators will be stateless, but they'll access that pending operation instance.
Okay. Or the event creator creates an event that marks the store as some kind of last operation canceled, because you probably cannot cancel the actual API call. So when the result comes back, the store already knows, like, hey, it's canceled, and just ignore the data.
Basically, there are multiple ways to model it, and since ReactJS and Flux is relatively new, not all scenarios have been well thought through. Okay, I see it's running pretty late here.
Yeah.
So what do you say we wrap it up? So if you have any questions, you can find me on Twitter at abdullah.com or on blog, which I showed up. And thank you for having me here. It was a pleasure.
Giving us so much like the Belgian beers, we provided you with, I think, 4 of the 6 existing Belgian piston beers.
Oh, that's the beers that brewed in the Abyss.
Yes.
Oh, thank you very much.
Thank you very much.